As I said, my name is Ben Wellington, and I am, in a lot of ways, a data scientist. I work at a financial company. It's called 2 Sigma. It's an investment management firm here in New York City. We've got about 1,000 people, most of which can code, so it's very much a tech company. However, on the side, I've been working on a little project for the last 2 years, and I'm going to tell you a little bit about that project today. The idea of the project was, can you take a blog and change the way city government works? It's a little crazy, but I experimented with this as someone who realized that cities across the world were releasing public data. So if you go back, I don't know, wherever you're from, a lot of cities today, and countries and states are putting up public data for anyone to look at. And it turns out that not a lot of people look at that data. When they put up a parking ticket data set, who's going to spend time looking at parking? I mean, I do. But other than that, I don't know who spends time. And so there's all these amazing things we can learn about our cities. And that not our cities haven't necessarily taken time to learn from themselves. And so in doing that, I've learned some best practices because as I started to write, in my world, I've always been into data, but then I married my wife, Leslie. She's an urban planner. And she would go to the stats class every week at the Pratt Institute in Brooklyn, which is an urban planning and design school. And she'd come back from this class and be like, why do I have to learn this? Stats is so boring. I'm like, no, it's not boring. Oh, yes, it is. So we kind of fight about this. And I realized that we're teaching stats to students in the wrong way, right? We're taking textbooks and we're making up problems and putting them in textbooks and then having students learn about fake problems when the world is full of real problems. Like, why are we using fake problems to learn when there's real problems? I went to the school and I said, I have an idea. You have all these urban planners. You're teaching these students with made-up data sets. My wife goes here, but I want to teach your statistics class. And they thought I was crazy. And I was like, no, just trust me. Let's take New York City's data sets and break them down. And if you're going to learn the t-test or correlation or all these things that, at its heart, most urban planners aren't, that's not why they went to planning school. Then at least let them learn about real city that they're living in. And so I did that, and that it went really well. The students started to actually kind of like statistics, which is a little weird. If you've ever taken a statistics course, I didn't like statistics. So this went on, and eventually, to make the homework interesting, I had to come up with really interesting, ideas and assignments. And I realized that it wasn't just my class that might be interested in these assignments. Maybe the world would be interested too, because what I would find in these assignments were these little problems about the way New York City was kind of operating. These little things you could find just using some descriptive statistics. We're not talking complicated modeling, we're talking very simple things. And from there, I started the blog. The blog's called Quant NY. For those of you who know the financial space, you might know where the word quant came from. But it's really the idea of quantifying things that are usually not quantified. Open data is not just a New York thing. How many of you have ever been to an open data portal before? Just a couple of you. You have your laptops here. Type in open data and the city you're from, and you'll find riches and riches of information. When open data first came about in 2012, it was viewed as all about programmers. And if you look at Mayor Bloomberg here in New York, what he said is, open data is a chance for computer programmers to enhance all of our lives. This is the 2012 view of open data, and things have changed a lot in the last few years because, what I believe, and at its core what I think is true, that open data is not just about programmers anymore. It's really about anyone that can get access to data. And if you build tools that are intuitive enough, you can actually get a lot of people using data to tell their own stories. So I see today open data kind of going through policymakers, nonprofits, anyone, not just programmers. The New York City Open Data Portal looks something like this, not very exciting, big buttons. But you can go to the Open Data Census and look up any city, and it shows you in a big chart what open data each city has. So there you see New York, Chicago, Austin, San Francisco, across, and at the top are different kind of data sets, 311 service requests, web analytics, asset disclosures, apparently asset disclosure again. Public buildings. So you get this huge grid and you can click and find a data set for your city. So before open data, we used to get plots like this. Did you ever think about the fact that every time you see a chart, it's somebody's narrative? It didn't occur to me until I started doing this work. This was put out by the Taxi Limousine Commission here in New York, and this is a view of taxis in New York by counting. But in open data, we can ask new questions. It's not just how many taxis are there, right? I was curious when rush hour was in New York City, and so I made this chart. This is the average speed of taxis in New York City per minute of the day. And I was wondering when rush hour is, and it turns out that taxis go fastest at 5 in the morning when they're going, if you took a taxi here, you might understand that, 24 miles an hour, and then things go south, and they bottom out at 11.5 miles an hour at 11:30. And it turns out there's no rush hour in New York, just rush day. Because it stays at 11.5 miles an hour the entire day. The entire day. This is not the kind of thing you'd expect New York City to put on nyc.gov, but with open data, we can ask our own narratives, right? It's no longer just a bar chart. It's whatever you want. There's an infinite number of questions we can all ask. So I started this blog, and one of the first things I did is this heat map. It was literally in the software QGIS. I went to File, Save As, Heat Map. There's nothing fancy going on here. But what is this? This is cyclist accidents in New York City. If you know New York, there's Manhattan or somewhere in the middle there. It's red, not a good place to cycle. There's a lot of cyclists, more injuries. But you can see things like Williamsburg, a lot of cyclists. And you have Roosevelt Avenue in Queens, also known as a corridor of... And I wrote about this, and something crazy happened. It started to get picked up by the press. And I literally went to File, Save As, and it started to... And someone said, I said that Williamsburg was a death trap. So, whoa, I never said death trap. Another article said Killingsburg. Suddenly, it was in the Atlantic. And I'm like, I went to File, Save As, and it's in the Atlantic. This is awesome. This is so cool. And I started to think, well, why is it in the Atlantic? What's going on? People love data. And I realized, what is it that I was doing? Well, there was data science, there's urban planning, and there's this third piece, and I'm half joking, improv comedy. No, not literally improv comedy, but I happened to do improv growing up, and you learn a lot of storytelling and data storytelling skills in improv comedy, and I'm gonna show you how some of those relate to some of the work, and why I think communication is key to data. It's absolutely necessary, because otherwise, if you do a bunch of data for other data nerds, no one cares. And most blogs out there, most analysis is, I wrote Python and I did and only like 1.1% of your audience is there. 99.9% of no, they don't care. So how do you bring it around? And that's some of the things I'm gonna, and I'll call that data storytelling here. So first of all, I think about connecting with people's experiences. What do I mean by that? In a scene, you might do a scene in front of a mirror where you're brushing your teeth, talking to somebody. Because you kind of all have been there and people are like, yeah, I know that feeling. I've brushed my teeth in front of a mirror. And so I think about that with my work. How do I get in the heads of New Yorkers? What do New Yorkers think about? And what other than Starbucks? I mean, we have them everywhere. So I decided to find the person in New York City that lived farthest from a Starbucks. Turns out it's the red star at the top of the city. You can go to their address, you can knock on their door, and I never did, but I've always wanted to. So did you know you live farthest from a Starbucks in New York City? It turned out that half of Manhattan was within 2 blocks, or 3 blocks of a Starbucks, which is pretty impressive. Another thing that people experience is, in New York, we have this weird problem where you can't get a cab during rush hour in the afternoon. This has been going on for 20, 30 years. You go out, it's 4 or 5 p.m., and they all have this little light on that says off duty. Like, what do you mean off? This is rush hour, why are you off duty? If you plot the entire revenue of the entire New York City taxi fleet per second, you get this chart. You see that big yellow dip? That is during prime rush hour. Why does revenue go down? What's going on? It turns out it's the shift change. Okay? But why does every cab do a shift change at the same time? That's crazy. Game theory. Turns out that there's only one time of the day that's equilibrium where my 12-hour shift and your 12-hour shift split revenue. It's a balancing act, right? If we switch cars too late in the day, the early driver gets more money. If we do too late in the early in the day, the late driver gets more money. And only during 4 o'clock is the trailing 12-hour demand equal to the next 12-hour demand. This is universal, so every cab driver does this. And therefore, we lose all the cabs at once, which lowers the entire revenue of the New York City taxi fleet by 3%. This is a 3% drop in revenue because it's locally optimal, but not globally optimal, right? It makes sense for me. So it would make more sense for me to just pay you to take the cab at a different time, but it's not the way humans really operate, right? If you plot the 12-hour demand, you'll see they cross right during that evening rush hour. So this is actually mathematically true as well, not just anecdotally. So what the city did is they put in a rush hour surcharge. If you catch a cab this afternoon, they'll add a $1 charge. Why? They say, well, let's solve this supply and demand, put more money out there, more cabs. What did that do? Put more money in the late shift driver's pocket. So what do the early shift drivers say? Hey, this is unfair, let's change keys later in the day, more into rush hour. So they went from the yellow lines to the blue lines. The equilibrium point is now worse, and we're all paying $1.50 every time we ride. So data is important for solving policy decisions, not just intuition, and this is where we stand today. How do you fix this? You rent out the cabs at different rates. So if you're gonna rent a cab from a thing in a 12-hour shift and it's not as optimal 12-hour shift, you charge them less. But we can't do that because New York City has put a cap and regulates the amount you can charge for a 12-hour shift. So we can't even shift the time and charge different amounts because of regulation. So that's where we are today. I also say focus on a single idea. Data sets have so many columns that everyone's, can be weirded out. This is a map of New York through the eyes of bike share, and what particularly the gender of our bike share riders. Is there a pattern? The yellow star there is about near where we are today, in Midtown. And you can see that 80 to 90% of riders of our bike share program are male in this neighborhood. If you go down towards Brooklyn, more pink, you see it's only 60% male. So this is a chart that people were really interested in. And if you think about it, it's a very simple narrative. It's one column of data, gender, along with some spatial data. There was lots of other data I could have analyzed. There are other visualizations out there that are amazing and beautiful, and they show flying bikes, and you see things, you all love the flying visualizations. But if I look at a visualization and I step back and I say, what did I just learn? And I haven't learned anything, then I consider it more art. I respect it, but it's not what I go for. I go for a learning moment. And here I learned that if you're looking for a date, I need to ride in Brooklyn. That's what I learned. No, I'm just kidding. But it's an interesting way to explore gender in the city through a data set you might not think about if you're studying gender. Also, I say keep it simple. So not just a single column, but your idea can be simple. Sometimes, look, I work in the financial industry, and sometimes things can get complicated. But a lot of the stuff I'm doing here in the city, very simple. People think they hear data science, they think of this. I use these guys, It's not so bad. Here's an example. I wanted to see where people from visitors from New York come, where they drive, and I just looked at parking tickets in every neighborhood. What % of parking tickets in every neighborhood are given to non-New York plates? What % in every neighborhood are given? That's a way to kind of a proxy of where non-New Yorkers are going. And sure enough, Manhattan lights up, Midtown lights up. But if you go to each individual state, you can see where people from every state drive into New York and get tickets. New Jersey, they don't really go into Brooklyn. They kind of stop in Midtown. I kind of know that. If you know New York, that makes sense. Connecticut, they're coming in from the north. My favorite, California. Californians only get parking tickets in the hippest parts of Brooklyn, in Williamsburg and Bushwick. This is real data. Californians only get, most of their tickets are in the coolest parts of New York. So we can rank our states by coolness. This is great. Thinking outside. And then what is this? I remember the New York Post called and asked about this. How did you do this? I counted. It's a ratio. These are ratios. We all understand what's happening. This is a percentage. There's a story sometimes to be told in a percentage. It doesn't have to be complicated. I also say explore the things that you know best. So a lot of you are experts in different areas. When you're using data, you can't just throw a bunch of data at the wall, see what sticks, and call it a day. You need to understand the domain you're working in. And if you're a lawyer doing a legal scene, it's going to go a lot better than just sort of a random person doing a legal scene in an improv or in a sketch. So excuse the small type, but I'll show you this. I've noticed in New York that we have these combination fast food places. Not every city has these, but have you ever been to like a Taco Bell KFC, or it's not just a Taco Bell, not just a KFC, but a Taco Bell KFC, or a Subway? Turns out, I had this idea just from being in New York, that the combination fast food places were less clean than the non-combination fast food places. This is the hypothesis I had. And in this world of data, we can actually test our hypotheses. So I went in, and I analyzed a combination, and what I found, all the way in the end, you see Dunkin' Donuts in blue, Baskin-Robbins in red, and then the combination was worse than either. And as you go up, things got really interesting. Taco Bell was in blue, lower is better. KFC is red, and Taco Bell KFC, above this line is a C grade in New York City on average. So we get A, B, C letter grades on all eating establishments. So while Taco Bell is an A and KFC is a very, very high B, the combinations on average are like more than double the individual restaurants. So my intuition turned out to be right just by looking at the data. While I was in there, I had to rank all the fast food in New York, because that's kind of cool, right? So what I found, it's hard to read, but at the very cleanest was White Castle. I don't know White Castle. If you do, it's kind of, then Taco Bell, then Starbucks, and at the least clean was IHOP. Now White Castle is a burger chain, and Fox sent a news crew down to the parking lot of one of these White Castles, and they're interviewing people, and someone has said on TV, I knew it was healthy. And I said, I never said it was healthy. IHOP put out a statement that basically said something like, he looked at 10 years of data, but had he only looked at 5 years of data, this wouldn't look this way. That's true. I mean, I looked at the full history. So once again, telling real stories just by looking through data. And you want to figure out what you're trying to measure. This is interesting too. Sometimes the things at your disposal, it's not just an average. That might not tell the story. And this is one where that's the case. This is a map of New York. Once again, this is gross. This is a fecal map of New York. This is where we have the most fecal coliform in our waterways. What is fecal coliform? Well, every time it rains very hard in New York City, it all goes down the drain. But our sewage and our drainage go into the same system. This is true, and not just in New York, in many older infrastructure cities. And what happens is if it rains a lot, the system can't keep up. So we have these things called combined sewer outflows. And combined sewer outflows, when rain gets too much, I don't know if it's a person in a room pulling a giant lever. I doubt it's not. I always picture, it's going to blow. But it's probably it's probably a button. And all the sewage goes out into our waterways. And this happens many times a year. This isn't rare. And then they put up signs on the beaches, beach closed 2 days. And you're like, okay, it's kind of gross. So I went to map this, and these red dots are places where they took, but I couldn't take the mean amount of fecal coliform because these were outlier events. Everything's fine, and then, oh, it's so not fine, and then it's fine, and then it's fine, and then it's so not fine. Couldn't take a mean. That didn't really make any sense. And I couldn't take a median, because the median was like, all right, everything's fine, nothing to worry about here, people move on. Most of the time, you can go. So instead, I was like, well, what do people care about? And this is always key. What are you measuring? And it hit me. If I was there, I want to know, can I get in the water? So I made a new metric, the percent of measurements where it would be not against the law to swim. What percent of measurements is it illegal to get in the water? If that's very high, that means it's always dirty. If it's very low, then it's generally clean. And that went more with what me as a reader might be interested in. So think about when you're making a metric, what are you trying to measure? Turned out that there was this place, Coney Island Creek, not the Coney Island you swim in, but behind it, where 94% of samples taken in the last 10 years had levels above legal state limits for swimming in water. And yet this is not what everyone's talking about because it's not in the most gentrified area like the Gowanus Canal here in New York, which is in a richer area, and you get a lot more attention. So this kind of data was interesting. One more example, in doing scenes, you kind of try to think outside the box, be original. Sometimes the data set you need is not where you think it would be. And I was wondering, when do people decorate for Christmas? Where can I get a data set about when people decorate for Christmas? And I found this data set where the government tracks injuries in ERs related to different objects. So it's actually coded. When you see, oh, this many people are hurt by a crib or by a chair or by a ladder. This data set also had Christmas ornaments and Christmas lights. So if you go in and you track the number of emergency room visits related to Christmas decorations from 2003 to 2013, you can see a spike during Thanksgiving. This was fit my intuition. This is a way to measure when people are putting up the Christmas decorations by looking at ER visits. So sometimes you look outside the box. And you can see that many more people are injured putting up Christmas decorations than taking them down. Because after Christmas, things seem to be a lot better. The green there is New Year's, red is Christmas, and the orange there is Thanksgiving. So really, it starts during Thanksgiving. There are people eating ornaments too. I won't tell you about that. Another one, really quick, I was wondering where the best illegal fireworks are in New York to watch. And how do you figure out where to watch illegal fireworks? Well, you look at complaints about illegal fireworks registered with 311 line. So if you map the complaints about people complaining about fireworks, you can get a map of illegal fireworks and go and enjoy. The next day, the New York Times wrote an article about the illegal fireworks in Inwood, which happens to be the place where I said were the most complaints. So sometimes you can arrive at the same place just by taking a quick count. And I'll end this by telling you some of the impact I've made here in New York City. Some small, some large. This is, if you read the subway, you might recognize this. This is the MTA Vending Machine. You can get a card. You only have to push 64 buttons to get your card, but that's another story. It used to look like this, where you had three options, 9, 19, and 39. There's a $1 fee. And what I realized is that no matter how many times I rode the subway, I always had a balance left over on my card. I couldn't get zero. I could not get zero. I rode every day. I go to work, refill, everything. And I went, and I was like, something's off. So I went and did a mathematical proof at home, and I showed that mathematically you can never empty your card. You literally can't. And I was like, wait a minute. And I read about how the MTA had tens of millions of dollars a year in unused balances. That was part of the revenue. And so they've given up these options, and you literally can't use the money on your card, all of it, ever. And this just seemed wrong. So I wrote about it, and I got a response from the MTA, the Metropolitan Transit Authority, saying, these machines do not hold an infinite amount of change. The denominations are suggested to ensure there is ample change to accommodate customers who pay with cash. That being said, we will look at this as part of the process involved in rolling out the next scheduled fare increase. They knew where to get me. So the next fare increase comes, and I go down to the machine, and I'm like, all right, nothing's going to change. But to my amazement, if you go down to the subway machine today, you will find not 3 buttons, but 4 buttons. There is a $9, a $19, and this new 4th button, $27.25, which I proudly proclaim if you push, you get exactly 11 rides. Exactly. So this is the only button. Now the red circle doesn't exist, and no one knows why this button's there but me. But I'm excited I got a new button added to the machine. And now I never have leftover balances on my last ride. If it's 0, I refill. It's not like, by the way, what I didn't mention is the middle button here gave you $19.95, and the fare was $2.50. Do the math. Remainder, $2.45. So you go swipe, sorry, you're a nickel short, and the train leaves, and you're just so angry. And this is the way. Now, we still live in a world where you can't go, hi, I'd like to buy 3 subway rides, please. Like, where else in the world can you not just buy what you want? In the New York City subway, it's like, I want to put this amount on my, I'll give you this amount on your card. I don't know what's going on. I wish that we could just buy 3 subway rides. Wouldn't that be amazing if you could just buy a ride from the New York City, buy several rides without getting 3 individual cards? Who knows? We're not there yet. A few other examples. This is health inspection scores in New York. As I said, we rank all of our restaurants A, B, and C. This is simple counting. The green are restaurants in A, blue is B, red is C. What do we see between A and B? A whole lot of piling up on the number 13, which is the lowest A possible, and not a lot of 14s. How do all these restaurants who are getting 1 and 2 point violations aim exactly for the border between A and B? How do they all get exactly 13 violation points and none of them get 14 violation points? If I had to guess, I'd guess the inspectors are, oh, I see someone going like this. I'm not going to make any insinuations about that, but I think maybe the inspectors have leniency during times, and that's not good for an inspection system. We want it to be a little more fair. I wrote about this, and the Department of Health said, inspectors are not instructed to offer leniency, just to cite what they see. The final score is based on the extent of the violations the inspector observes. So they basically said nothing, unfortunately. But if I had access to the individual inspector IDs, then you can make one of these charts for each inspector, and it would be obvious who is doing this. That would be, but unfortunately, they have that data, I don't. Another thing I learned in New York looking at data was that our cabs, you ride a cab and you get this screen at the end if you pay by credit card. Do you want to tip 20, 25, or 30%? Or other? 20, 25, 30, or other. And for the last 10 years, I went about, and then I stopped and said to myself, well, I was doing some analysis and I ran into something and I realized, what are you tipping on? 20% of what? No one's ever stopped and 20% of what? Is it the base fare? Is it the base fare and taxes? Is it tolls? What is it? Is it the rush hour surcharge? It turns out that it depended on the manufacturer of the computer in the back of the cab. For the last decade, half of the fleet of New York cabs created by Creative Mobile Technologies was tipping on top of taxes and tolls. And the other half, created by Verifone, was only tipping on top of base fare and surcharge. So the drivers of one computer in the back made $300 more a year from this software change for the last decade. No one noticed this until open data came about, and I did some analysis and wrote about it, and the Taxi and Limousine Commission wrote, we appreciate the work that went into his analysis, and we're giving it a thorough read. That's a great government quote, if I've ever heard one. A week later, they reprogrammed half the fleet of New York cabs. Now we all tip on top of tolls and taxes. But at least it's equitable, right? At least it's equitable. At least it's change, right? Okay. 2 more examples and then I'm done. The 5th Precinct, if you look at the back of police cars in New York, they all have Twitter handles. Amazing. This is a tweet from the 5th Precinct. The 5th Precinct had a 115% increase in bicycle collisions this year. Police officers will be enforcing violations by bicyclists. #bike, space safety. So the 5th Precinct now are awesome. They're tweeting math. This is great. So I was like, well, show your work. I'm going to go check this out. Imagine a world where our governments showed their work. Instead, I went and looked at the work. 115% increase, more than double the number of bicycle collisions. Nothing double, like unless you make a volcano, nothing's going to double. So I went and looked, and in fact, there was a reduction in the number of bicycle collisions. And there they were, sending all these officers, so I wrote about that. And the NYPD, well, they didn't say anything. And lastly, there's this guy. This is a map of fire hydrants in New York City, but they're mapped by parking ticket revenue generated by the fire hydrant. Every fire hydrant has a revenue associated with it, right, per year. You got a little too close, gotcha, $250, $250. So I decided to map these hydrants. These are the top 250 in New York. I found that the Upper East Side really, really loves giving these tickets. It's not because there are more hydrants, I checked. But I also found these 2 hydrants in the Lower East Side. These hydrants make more than minimum wage just being hydrants. They're making $60,000 a year, over $55,000 a year. Now one of them it's in Chinatown, and one of them had a little sign in Chinese that said, do not park here. So if you could read Chinese, you were okay, but otherwise, it was literally on a hanger with a piece of paper, and it lasted for years. It's pretty neat. So I wrote about this, and the Department of, and what's going on here? Well, we had a hydrant, and then what looks like a bike lane. You know those separated bike lanes? Then there were parked cars. And so this car would come park here. I'm not next to the hydrant. There's a whole lane between me and the hydrant. And the Department of Transportation said, yeah, of course, we'll paint a parking spot. And the New York Police Department said, no, I don't think so, and kept ticketing this cars for 10 years. For 10 years. $50,000 a year, it's not bad. If you look on Google Street View and you go through the years, you will see parking tickets on the windshields of cars in Google Street View. You can click through the years and you see parking ticket. It's a lot of fun. I was like, that's when I knew this was real. So I got a statement from the Department of Transportation. While the DOT has not received any complaints about this location, we will review the roadway markings and make any appropriate alterations. And I said to myself, all right, nothing's really gonna happen. But 2 weeks later, what happened? They repainted the streets. They repainted the streets here in New York just because I'm counting parking tickets. This is descriptive statistics changing the way a city operates on a small scale. Can this be a bigger scale? Yeah, as more data becomes public, we're gonna have more opportunity to help our governments. We're also gonna have more opportunity to help our companies, right? As companies get more comfortable sharing data internally, maybe people can start doing more with that. And you don't always know what that could be. I don't think when the government releases this data, they don't know what's gonna happen, but there's some long-term faith that in the end, they're gonna get a benefit out of it. And I think a lot of corporations are realizing this as well. Not every data set needs a great reason to be out. I mean, you obviously have to be careful of privacy and things that you can't share, but other than that, New York City, the laws now, or the default is that it's open unless it shouldn't be for a reason. It's not the opposite. It's not, we need to put it out when it's asked for. It's assumed that it's gonna be public unless there's a privacy concern or some other issue. And so I want everyone to think about that within a corporate setting as well, not just government, what that could mean for the future. So I didn't get a quote from the NYPD on this one, but coming out tomorrow on my blog, my first NYPD quote, I've convinced them to retrain. I finally got them on something a little more systematic than this one, which is millions of dollars of parking tickets given to legally parked cars across the city because of a training mishap with officers. So tomorrow I'll be writing about that along with the police department's response to that. And so that's a much larger thing. They're going to be retraining officers across the city because of open data, which is the beginnings of what the future of government could look like. So I'm pretty excited about that. So data storytelling, connect with people, keep things simple, convey an idea, explore things you know best, figure out what you're trying to measure. That's a big one. Sometimes that takes a lot of time. What are people asking? I don't know. And think outside the box. I'll show you, just to end, this is the New York City Open Data Portal. This is just some raw data you can download in different ways. And this is one of my urban planning students, just learning Excel pivot tables, which is kind of the gateway to data analysis, I say, was able to kind of make this chart looking at accidents around the school and what they're being caused by. So this is not someone who knows nothing about coding, nothing about computer science, and we're starting to analyze a data set that had thousands and tens of thousands of rows. And even if you can't make that, this is from a high schooler tracking graffiti around New York using colored pencils. So it's the beginning of what could come very soon. So I would argue that anyone can be a data storyteller if they don't get stuck on the subway and late for a keynote. Thank you so much.